Welcome back, everyone. Today we're going to be continuing right where we left off in the last video, discussing the complex valued function e to the ix. Now, as we discussed in the last video, the value of e to the ix will always lie on this unit circle, radius 1, in the complex plane, where the angle of the vector, if you want to call it that, pointing at that point on the circle, that angle to the right side of the real number line will be x for any e to the ix. Now, we are going to take this concept and realize that if we have a unit circle like this, starting from here, any angle theta, if the radius is 1, then we can drop an altitude here, and we say that if this angle is theta, then this must be sine of theta, and this must be cosine theta. Essentially, the x value of whatever this point is, right, it'll be some point x comma y, the x value is defined as cosine theta, and the y value is defined as sine theta. Now, taking that to the complex plane with e to the ix, we have a circle with radius 1, and we have an angle. So we see that this point must be cosine x for the x value, but then the y value is going to be in terms of I, but it's going to be sine x. Cosine x, sine x. Now, what this means is that since e to the ix is actually this point, we can say that e to the ix equals cosine x plus I sine x. And this is true for any x. Now remember, the goal of this video is to determine trig derivatives, and in this part of the series, we're going to be determining the derivative of sine. So to do that, we're going to take this relation and we're going to rework it in order to find the derivative of sine. So to begin, we're going to take the derivative of both sides, and we see that on the left side we get I times e to the ix, that's just by the chain rule, is equal to the derivative of cosine plus I times the derivative of sine. However, cosine, as we know, can be rewritten in terms of sine because of this identity. Sine squared x plus cosine squared x equals 1. Again, I'm assuming you're taking calculus if you're watching this video, and so you should be familiar with this trigonometric identity already. And of course, rearranging this, we can say that cosine x is equal to the square root of 1 minus sine squared x. We're going to be using this in our calculations. Plugging this in for cosine x, we get that I e to the ix is equal to this whole expression. And now we have everything in terms of sine x on this side, and we can use the chain rule to begin to simplify this expression. Now this may look a little intimidating, but we see that it's just the repeated chain rule. So we have the derivative of this square root of 1 minus sine squared x expression. So we rewrite it as 1 minus sine squared x to the 1/2 power. And so by the power rule, we bring that 1/2 down to the front as a coefficient. You subtract 1 from 1/2, you get negative 1/2. And now we multiply by the derivative of the inside. Now we keep this expression, bring it down. And then the derivative of this, the derivative of 1 is, of course, going to be 0, so that'll cancel out. And then the derivative of negative sine squared x, we're going to have negative 2 sine x to the 1, right? That's just power rule. You bring the 2 to the front, you subtract 1, but then you have to multiply by the derivative of the inside, and the derivative is, of course, just whatever the derivative of sine of x is. That's what we're solving for. And so we get this final thing as our whole expression. 1/2, 1 minus sine squared to the negative 1/2 times negative 2 sine x times the derivative of sine x. So let's plug that back in here and then compress it a little bit and see what it looks like. After plugging it back in here, we get this nasty expression. Now, we see that this 2 on the denominator and this 2 on the numerator will cancel, so that's nice at least. And we see that we have our derivative of sine x term here and here, so let's factor that out. Factoring it out, we see that I e to the ix must equal the derivative of sine of x times this expression, I minus sine x over square root of 1 minus sine squared x. Now, we're done with all of the chain rule shenanigans that we're going to be doing, so we can actually put this back in its normal form of cosine x, and we see that since sine over cosine is just tangent, we can rewrite the expression like this. Now, we can just divide both sides by this I minus tangent x in order to isolate our derivative of sine x value. And so we're going to get an expression that looks like this. That the derivative of sine x must equal I e to the ix over I minus tangent x. Now, let's clean this up a little bit. First, we'll bring this expression down to simplify by itself. The first thing that we can do is multiply by this fraction I plus tangent x over I plus tangent x. Now, of course, when you multiply by something over that same thing, you're really multiplying by 1, and so this expression won't change at all, but look at what happens. On the top, we bring down, we'll multiply by the tangent x first. So we have I tangent x e to the ix, and then I times I is -1, so we just have minus e to the ix over. Now, I minus tangent x times I plus tangent x. This is a difference of squares. So we'll get I squared minus tangent squared. But I squared is, of course, -1, so we get -1 minus tangent squared x. So, bringing that up, we'll factor out a negative from this denominator. We get negative I tangent x e to the ix minus e to the ix over 1 plus tangent squared x. But of course, this is a trigonometric identity. We know that tangent squared plus 1 is secant squared. And now, we'll take this negative, apply it here so we can switch the order of this subtraction. And we have e to the ix minus I tangent x e to the ix. And then we bring up the secant squared. Since secant is 1 over cosine, secant squared is 1 over cosine squared, and 1 over cosine squared is going to be just cosine squared. So we have this expression here. Now let's simplify further. We are going to recall that this tangent x is just sine over cosine, and then we're going to factor out this e to the ix on the outside here. Now we're going to take one of the cosines from this cosine squared and bring it on the inside here so that this and this cancel, and that this one also just becomes cosine x, and we get this expression. Now, we bring up the same expression as before, except we recall that e to the ix is cosine x plus I sine x. Now we have a plus b times a minus b, so it's another difference of squares. What we'll have is cosine squared minus I squared sine squared. Now I squared is of course -1, so the minus will become a plus, and we'll have sine squared. But again, remember this identity. Sine squared plus cosine squared, or cosine squared plus sine squared. Again, addition is commutative, so it doesn't matter what order we do it in. Cosine squared plus sine squared is always equal to just 1, and therefore we have 1 times cosine x. But remember what this whole expression was equal to, that the derivative of sine x is equal to cosine x. There you go. There are a couple of other ways I've seen the derivative of sine x be proved, but they usually involve something that takes a much higher understanding of calculus, or it takes something that is not very intuitive at all, like not even in the slightest. And so I thought that this would be a nice way to show the relationship between the derivative of sine x and cosine x by using their relation to the complex function e to the ix. Because that way, I get to teach you a little something extra along the way about complex functions. Anyways, we'll be proving the rest of the trig derivatives in the next video, closing out this series. But I'm hoping that you were able to learn a lot from this video, and that we've shown the first trig derivative, that the derivative of sine x is equal to cosine x. Thank you so much for watching.